All right. In this chapter, I know, I just unfroze it. Thank you for telling me. In this chapter, we're going to be talking about transformations. In middle school, you talked about transformations as slides. Oh, running low on battery already. As slides, flips, and turns. Slides, flips, and turns. Okay? So, a slide is a translation. We're moving one thing from one place to another. A slide, we're moving it. A flip, we're flipping it across a line. And a turn, we're turning it to be a different direction type of thing. A slide, flip, and turn. So a slide is a translation. A flip is a reflection. And a turn is a rotation. That's the words that we'll use in this chapter. Those are the three things that we're going to talk about this chapter for the most part. Now, the part that the figure that we start with is going to be the pre-image, and the image is what we get after we do the transformation of some sort. Okay? And if it's a rigid motion transformation, then that makes congruent figures. Okay? Because it's the sides will be the same length and the angles will be the same size. Okay? So, a rigid motion, and another word for rigid motion that we'll use in this chapter also is isometry. So, if you see the word isometry, it means the same as rigid motion. They're going to make congruent figures. Congruent figures. Now, does this look like a rigid motion? Do they look like congruent figures? Same size, same shape? No. They're the same shape, but not the same size. So that is not a rigid motion. This thing is called a dilation, which we'll talk about in a different chapter. Okay, we'll talk about that in a different chapter when we're doing similar figures. All right, a reflection is a transformation that reflects each point of the preimage across a line. So here's our line of reflection. Okay, here's our line of reflection. If A is on the line of reflection, it won't move. It stays in the same place. However far C is from the line of reflection, you go that far past the line of reflection. However far B is past the line of reflection, you go that much further to get to the next B point. So that's a flip or a reflection across the line. Okay? When you reflect across the line, you have to go perpendicular to the line and go the same distance across the line. Okay? So we're going to reflect FGH across this line. So then G is about yay far from here to here. So we'll go the same amount. And that's where G prime will be. You put a little asterisk on the letter to denote that that's the image. Okay? Then the resulting figure. H was this far, so if we go this far, H prime is here. F is way out here, so we'll go way out here again. And this is F prime. And that's the resulting flip across the line. When we flip it across the line, it's called a reflection. Okay? So, a lot of times we're going to flip across the x-axis or the y-axis. When we flip across the x-axis or y-axis, we need to list the new ordered pairs. Okay? If we're flipping around across the x-axis, they want f prime first. It's at 0, 3. It's 3 above the x-axis, so it'll go where? If it starts 3 above, then you go 3 below. There's f prime. So it's at the point 0, negative 3. G is 4 above the x-axis, so we go 4 below the x-axis. There's G prime. It's at 2, negative 4. H is 2 above, so it goes 2 below. So it's at 4, negative 2. And J is on the x-axis, so it stays there. So J prime is also there. Okay? And so it is at negative 2, 0. Okay? So what did we do there? When we reflect across the x-axis, what happened to all our y values? They became what? If you say negative, that works for this one, but they became the opposite sign. They became the opposite sign. Okay, so if you reflect across the x-axis, your x doesn't change, but your y becomes the opposite. So when you reflect across the x-axis, your x doesn't change, but your y becomes opposite. If we reflect across the y-axis, your y doesn't change, but your x becomes opposite. Okay, that's really important to know. Okay, when we take the test, on the test, it'll be like 3 pages or 4 pages this next chapter because we have more to, there's the pictures are bigger and stuff. So you're going to have all kinds of ordered pairs to fill in on the test. I want to know where the ordered pairs are, where the points are. Okay, so that'll be important, finding where the ordered pairs are. So if you reflect across the x-axis, you change the y, leave the x alone. If you reflect across the y-axis, you change the x, leave the y alone. All right, what are the coordinates of if you reflect across the y-axis of ABC? Okay. A was at 3, 2. B was at 1, 4. C was at negative 2, 0. Where's A prime, B prime, and C prime? Well, when we reflect across the y-axis, what do we change? The x to the opposite. So it's negative 3, 2, negative 1, 4, and positive 2, 0. Negative 3, 2, negative 1, 4, and 2, 0. Okay? Are we good? All right. The next one is reflecting across the line x equals y. This is the line x equals y. When you reflect across the line x equals y, what's the pattern that you see? What happens to the numbers when you reflect across the line x equals y? They just switch places, right? So when you go across the line x equals y, it becomes yx. You just flip them around. They just change places. Okay? Negative 3, 5 becomes 5, negative 3. 1, 3 becomes 3, 1. And negative 1, or negative 5, 1 becomes 1, negative 5. Okay? All right. Chandra wants to roll the ball A so it bounces off the ball and hits ball B, kind of like pool. You aim and you want to hit it off here so it hits here. Now, how does she do that? Well, she needs to find a point where if it would go straight through, then this distance would be equal. Okay? Where that distance would be equal. Wherever that would be, that's where she wants the ball to intersect. So these would be equal to each other. All right, reflections. A reflection is a transformation that reflects a point in the preimage across a line of reflection. Okay? So let's take an example of this. Now what we're going to do is reflect across the line x equals 1. Okay, we're not just doing the x-axis or y-axis. We're going to actually reflect across a different line. The line x equals 1 has the points 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and so on. It's this line right here. This is the line x equals 1. Okay, that's the line x equals 1. If we reflect across it, B was 1 to the right, so it goes 1 to the left. C was 1 to the left, so it goes 1 to the right. A was 2 to the left, so it goes to the right. So that's where A prime, B prime, C prime is. If we reflect across the line, x equals 1. Now let's reflect across the line y equals negative 2. Y equals negative 2 contains the point 0, 2, 1, 0, negative 2, 1, negative 2, and so on. So it's a horizontal line right there. Okay? So, if C is on the line, C stays on the line. If B is 2 above, B goes 2 below. If A is 3 above, then A goes 3 below. And that's a reflection of the red across the line y equals negative 2. Okay? So, you will be reflecting not only across the x-axis and y-axis in the line x equals y, but across different lines.